Hi, thanks for checking out one of our videos here on YouTube. This is going to be a kind of a test and review video on this particular unit and model. This is a Gallagher M10000i. This is probably one of the strongest units produced in the whole entire world. 100 stored joules, I think about 70 output, something like that. It's not full 70 output all the time because this is an adaptive output unit. When you get into, at least on Gallagher's, when you get to about the 11 joule stored and larger, all their units are an adaptive output. They don't use all the power all the time. They use what they feel they need to use based on the load that's hooked up to them. So if it's a smaller fence or a cleaner fence, less stress, then the unit only uses what it feels it needs to. So it might only use like 20% of its full potential. And until it starts feeling more and more load increase, whether you add more wire, grass gets on the line, dead shorts, problems, whatever, animal touches the fence, well, it feels a resistance increase, so it'll gradually build the chart up to a next higher level of joule output based on that load. But as soon as the load goes away or burns through the grass or you fix the shorts, whatever, well, it feels less resistance and it lowers itself back down to a lower level. Kind of think of it as like cruise control in a car. So if you're going, and we'll see this in this, we'll see this, what I'm talking about when we use my load deal. We're going to hook up to it and we'll see the voltage and the joules kind of change. And based on the load, you'll see the voltage drop and climb back up, sort of thing. So like I was getting at with cruise control on a car, if you're doing 65 miles an hour down the highway and it's a nice level highway, no hills or nothing, well, the throttle on your car might only be pushed down by 10% of the throttle just to maintain 65. But as soon as you climb and start hit a hill, go up that hill a little bit, well, the car feels more resistance, so it's going to press that pedal down to try to maintain 65 miles an hour. So it might use 30, 40, 50% or all 100%, I guess, worst case, to give more power to try to maintain 65. But as soon as you hit the top of the hill there and levels back out, well, the car feels less resistance, no more hill, so it lowers the pedal back to a lower level. So that's, kind of think of it like that. A lot of brands, honestly, don't do that. Like Zariba, their 6 joule or 15 joule stuff. A lot of the Cyclops in their mid-size, like the 12 joule and smaller. Some of the Speed Rights, a lot of brands don't do that. And that's why you don't see them last as long, because they're running full power all the time, even on when they don't need to. So that's why the parts get hot, because they're trying to put out, I don't know, let's just say a unit was made for 350 acres and you got it on 27 acres. And it's nice, normal 4-wire fence. Well, there's not a lot of resistance there for what the charger's designed to put out. Well, all that extra power that it can't get rid of gets dissipated as heat inside of the parts. Not really, ambient temperature will get warm on the inside, which is normal, but like the actual components, the transformers, the boards, parts in the board will get warm. Well, because they're trying to get rid of all this energy and it can't, because there's not enough fence out there. And so that's why some units, some brands only go 3-4 years, 2, 4, 5 years before they crap out. This unit is a 2018 model. And so like, well, why the hell, it's a Gallagher. It should have lasted longer than that, because we're in 2024. What's that, 6 years? Well, I'll show you why it went bad. Power surge. Lightning got a hold of it and burned the hell out of the thing. And luckily, capacitor, every single capacitor was good. And it's got about 12 capacitors in it. Two transformers, a primary one and a secondary one that kicks in for when it needs to. But both the main module and the logic board were destroyed. Here's the 2 boards in it. This is the logic board. This one tells it kind of what to do. And it has a remote control communication stuff built onto it, as well as the monitoring stuff, as well as communication for the display controllers built on this board. And then it also has, it tells the main board what to do when it comes to the amount of load that's hooked up to it, because this board plugs into both here and right there. But this port right there is like a phone jack cable looking thing, and that's where the digital controller plugs in at. But you can see this board is all burnt up. All those bunch of little bitty parts up there all burnt up over here. I mean, you really can't fix this stuff, and it's also burned up over here. This is a spark gap for fence and ground hook up at, but this board's burned up as well. But look at the back side; it's a complete, utter mess. I mean, it's just a mess. And I've seen worse units get burned up worse than that, but that one is definitely bad. And then there you see the primary, one side of the primary, the transformer area, the board's all burned up over there. And look over on the flip side, where it's same area, it's all burned up there. There's the AC input sides right here. It plugs in these two little tabs right there. And on the flip sides right here. So I don't know if the fuse is any good or not, but they blew up the MOV. It has burned up the traces. And there's some little bitty parts up in here that are burnt. You can't get schematics for none of this stuff. So you have 9 times out of 10 you're gonna have to just replace the board, you know, when they get this bad. So it's a pretty fancy board. I mean, it's a nice setup on the board. You can see everything's all like in line. You know, there's channel 1, 2, 3, 4, or I think 5 channels on this thing, and all the capacitors plug into these things here and flip it over. You see they are lined up where all the capacitors set. There's 12 of them. Each one of them are 15 microfarad. I think 2,000 volt or 1,200 volt. I can't remember now. Capacitors on there. They're pulse grade. There's 12 of them on there. You see it goes all on a line on here. And so this unit, like I said, up here, it's staged up here as well. There's different stages. And like I said, this is an adaptive unit, so it only uses, one channel at a time. Maybe 2 at the most, or on one channel, or one situation might use one and after 2. And as soon as it feels more resistance, well, it starts grabbing more capacitors, more channels. You can see each channel down here on there. And it does that to increase the joules, add more capacitors in the mix. It also has that secondary transformer into it. So it's a very smart unit. I mean, these aren't cheap, but you're looking at 100 stored joules. I think it peaks out about 10,000 volts. So I mean, it has a lot of voltage and a lot of. I'm gonna pause this video real quick. I'm gonna back this camera out a little bit so I get more stuff in the frame here. All right, there we go. All right, so what we're gonna do is this digital controller is plugged into the unit on the back. We're gonna pop this orange cover off here. Kind of a pain to get off here sometimes. That just kind of covers up the fence and ground terminals here at the bottom. And we're going to go ahead and hook up our leads here of this energizer performance meter, they call it. It tells us a lot of information about a unit. We can put it under different loads and stuff, and it will tell us the joule output, not the stored joules, but the output joules under different loads. And that does open circuit. When the built-in loads that are on this unit, there's external ones I can buy and hook up to it and set on the different ones to kind of see, fine-tune kind of load, and you actually get heavier loads on it than what this one can produce. But this goes all the way to 100 ohm load, which when you go across fence to ground, which is 0 ohms, would be a dead short, or 1 ohm, I guess, would be a dead short across here. So it'd be basically a dead short would be a direct hard low, which would be a 0 or 1 ohm short across it. But the heaviest we can go on with this thing is 100 ohm, and that's pretty heavy for a lot of mid-sized units. But this one will probably just laugh at it. So let's we'll turn this on. We're going to do open circuit voltage, and we're going to see the amount of joules this puts, or amount of volts this puts out. And this will read up to 12,000 volts, this particular deal. So let's turn this on. You kind of saw that. I was kind of see that. You see how it kind of gradually climbed that number up. That's your kilovolts. So we're under no load, so that's why there's no amps showing up. And see where our tester over here is reading 9.8, so it's basically the same. Oops. That's what will show up on here. So let's let's turn this off because I don't want to get shocked by accident. Let's put this over to 500 ohm load, which is kind of the standard load. Well, we'll do 1,000 first. We'll do 1,000 ohm load. We'll turn this light off, see if we can get rid of the glare. Let me turn this light on. That's not too bad. Okay, so we're going to watch two things. Right here is going to be our joule output based on this load that's hooked up. And there's our voltage. And you'll also see the voltage on this change. It will grab, and the amps will also pop up. But you'll kind of see how the numbers will be on there. And let me put this to 1,000. See, we got a 10 amp load based on this number, based on this load to this unit. And with a 1,000 ohm load, running almost 10,000 volts still at 4.5 joule output. Now let's, I'm going to use a screwdriver because I don't want to, not a screwdriver, but a pair of plugs. I'm going to move this from here to here. I want you to watch the amps will go up because we're putting a heavy load on it. And the voltage will probably be dropped a little bit and climb right back up again. So I'm going to put this to 500 ohm there. I'm going to take this. See, it fell down and went back up. Now we're sitting at still 10,000 volts, 21 amp load. And we're sitting at 10,000 volts, basically at 8.5 joules output. Now we're going to turn this to 200. Move this to 200. So it's climbing back up. Now we're at 10,000 volt, 50 amp load. And if we look at here, we are at 20 joule output at 10,000 volts still. But you saw how that number fell and it climbed back up again. That's the unit adapting it, so it gets dragged down and it builds itself back up. So it's like the car is driving down the highway, hits that hill, like, oh God, oh, give it some more throttle, crank it back up, get back up to 65 miles an hour or 10,000 volts. So now we're going to go to the heaviest load that I can put on it with this particular setup. So we're going to go to 100 ohm over here. And we're going to take this. Keep watching it. Look at that. 91 amp load. And we're, see, 100 ohms would about kill about most large or mid-size units, would really drag it down. We're hitting a 100 ohm load. We're at 9.2 kV at 91 amps. And look at this. It's not even at its max potential. We could really drag this down and get more joules reading out. But we're at 33 joule output at 9,000 volts. So we would really have to find. Let me see if I've got a heavier load I can put onto this thing. I don't think I do. I've got, well, here, I've got a 75 ohm. It's a 300 watt, 75 ohm resistor, basically. So let me turn this unit off. I'm going to get this wired up. So now we have to switch this over to an external load, which there's some down here and a bunch over here. So I'm going to put this to the range 2. And then I've got to match it up to 75, which is the third one there. So that's that. So now it's going to, of course, it's going to be higher than 1 joule, or 33 joules, I'm sure. And we're also going to be at a higher, hold on. Yeah, more joules is going to show up, I'm sure, probably 40 something, who knows. But I know that you can load these things really hard, and they'll run about 200 amp load, and it'll still be putting out about 5,000 volts at like 70 joules, something outrageous. But these things are monster strong units. I mean, these things, there's not much that holds a candle to them when it comes to being able to power through problems and load. So but they aren't cheap. They're well over here in the United States, in United States. They're about over $3,000 for these things. There's a lot of stuff that this unit can do that other units can't. The ring connector I got on this thing is it's a little too small to go on the thread, to go on the bolt. So what we'll do is we'll sandwich it. See if we can sandwich it between the leads here, between the washers there. So we'll do that there. Okay, we're at 75 ohms. And we'll see what the joules jumps up to, what the voltage falls down to. We'll also see what this thing will max out at. We're at 9.1 with 100 ohms. Now we're at 75 ohms, so we're getting closer to 0 ohms. Watch it climb. Look, climbing up. Now it's really, really punching. Look at that. 75 ohm load, which is kill about anything out there. And, that's in that 20 joule or less, probably 35 joule or less. We are running at 10,000 volts still, roughly, at 50 joule output with 75 ohms. This is a 70 joule max joule output. So look, it's still pushing 10,000 volts through 75 ohms. This thing is a beast of a unit. It just punches right through stuff. See, the worse the load is on a unit, the higher this amp number will climb based on the load that's hooked up to it. So if we turn this off and unhook this, and we'll go to no load again. You gradually adjust itself to what it needs to do. And it feels like no load hooked up. $10,000 volts. So this unit tries to maintain 10,000 volts all the time. So based on the load that's hooked up, it will adjust the power output and bring in more capacitors, that extra transformers built into the thing. So these adaptive units that Gallagher's got. They've been doing adaptive control stuff for like 40 years, probably 35, 40 years, since the late 80s at least. And on all their larger unit joule stuff, 20 plus joule stuff, they've had adaptive output for a long time. So it's not like it's brand new technology. It's been around for, well, at least with Gallagher, it's been around for 40 years, roughly. They started bringing that adaptive output into their 11 joule stuff, which like the mid-size, called the M1100, at least here in the States, called the M1100, and larger. They all are adaptive outputs when you get to that size. This is an I version, so it has all this fancy accessories that you can buy, hook up to your system, depending on what kind of system you want to have and what kind of information you want to gather and keep tabs on. But these units are, nothing competes to this thing. This unit just will run circles, energy-wise and performance-wise, just about anything out there. I'd put money on it. They would outlast and outperform a lot of stuff that's out there. Now you can't beat these things. A lot of the Gallaghers are like that. A lot of the Gallaghers are really good. Expensive, but they perform well. They're like buying a Speed Queen washer and dryer. They'll cost you a lot more, but they'll last a lot longer. I mean, if Lightning hadn't got this thing, it'd still be running. So... Well, anyways, thanks for checking our channel here, our video. If you ever need parts for a fence charger, we would be happy to, help you with parts if we can. If you'd like to send us something to be worked on, be happy to work on it for you. And until next time, we'll see you guys later on, and have a good rest of your day.